Today we're going to do a crash course on Pydantic AI, another one of these agentic Python frameworks similar to LangChain and Llama Index, for both of which I have tutorials on this channel. And as always with these agentic frameworks, they're slightly different. For the most part, they are quite similar, but they do have a different focus point. So LangChain is the more generalistic end-to-end framework that is a little bit like Django, you could say, a lot of batteries included, opinionated. Then Llama Index is more focused on retrieval, and Pydantic, which we're going to cover today, is more focused on validation, type safety, structured output, and in general, it's more minimalistic and flexible, a little bit like Fast API. We're going to cover quite a bit today, so if you like this video, let me know by hitting the like button and subscribing. But now, let us get right into it. Alright, so Pydantic AI is what this crash course is about. It's another one of those Gen AI agent frameworks similar to LangChain and Llama Index, as I already mentioned in the introduction. And you can see they say here it's the Pydantic way. So for those of you who don't know what Pydantic is, it's basically a Python package used for validation in a lot of different contexts. One of them is Fast API, but also Pydantic is being used by many of the other agent frameworks. It's used by LangChain and it's also used by Llama Index. And this is also one of their arguments here. When you go down to why use Pydantic AI, it basically says here, why use the derivative when you can go straight to the source? But on a more serious note, the actual reason to use Pydantic AI is to some degree a matter of choice. So some people just like the Fast API style of building these agentic applications. A lot of people in the community think that Pydantic AI is just much cleaner than LangChain in terms of how the code is written and in terms of how you write code using it. But also it has a different focus. It's very focused on being production ready and type safe and validating stuff and doing structured output. So that is the focus here, similar to how Llama Index is focused on retrieval. You can use all of these frameworks for basically everything, but they have certain strengths to them. And this is the focus or the key selling point here of Pydantic AI, I would say. So enough of the theory, let us get started with the setup. For this, open up a terminal, navigate to the directory that you want to be working in my case, the tutorial directory, and here you can set up a virtual environment. You can also just use your system installation if you want to. So the simplest way to do that is to just say pip or pip3 install the packages that we're going to use today. I personally always prefer to use UV, so I'm going to initialize a UV project with UV init. And I'm going to say UV add instead of pip install. So whatever I say here after UV add, you can just say after pip install, and it has the same effect just on your system installation. So what we're going to need here is Pydantic-AI, but we're also going to need python.env. And one more thing that we're going to need is also Jupyter Lab. This is the environment that we're going to be working in today. This is optional. You can also just work in ordinary Python files. I just prefer Jupyter notebooks when we learn something because we can interactively run cells separately. We don't have to run full Python scripts. So install these dependencies and then we can do Jupyter Lab in order to start Jupyter Lab. And if you're using UV like me, you have to do UV run Jupyter Lab. So this is just going to open up the development environment. As always, when I do tutorials in Jupyter Lab, I briefly explain what the environment is about. So here we don't work with Python files, we work with interactive Python notebooks. It sounds more fancy than it is. We just have individual cells of code that we can run. So I can say a equals 10 and I can say print a down below. And then I can also do multiple print a's and I don't have to run the entire code from top to bottom. I can run individual cells and I can also run them in different orders. That just makes it easier to interactively work with stuff as you're exploring a package or a data set or whatever you're doing. Now, before we start with the coding, one more thing needs to be set up. You need to have a .env file containing your API key of the provider that you want to use. You need to use some large language model, obviously, to power your agent with intelligence. So you want to go into your directory that you're working in. And in my case now, I'm going to copy this from my prepared code. So I have a YouTube preparation library here. I have a Pydantic directory. And I have a .env file in here. Now, I'm not going to show my .env file because this .env file contains the API key. But what you want to be doing is you want to create a file called .env. So just a dot symbol, env. And in this file, you want to have an API key. I'm going to say test here to show you what this looks like. That's just going to be the OpenAI API underscore key, for example, if it's the OpenAI key, otherwise Anthropic or whatever you're using. and then whatever the key is. So you just put the key here, and then you save the file like this. That's basically it. That is a .env file, and it's going to be relevant because that is going to automatically be recognized by Pydantic if you try to use an OpenAI model, and it's going to automatically authenticate yourself with the OpenAI API. So let's get rid of all this, and let's start by importing from .env the function load.env. This is why we installed python.env, because this function call here allows us to load the API keys from the .env file. Alternatively, of course, you can also specify them with an export statement in the terminal if you want to, but that is the easy way. You just create a .env file, put the keys there. You can also have multiple keys in there, and load.env then loads it into your script or application. So that is the setup. Now, what I always like to do when exploring these agent frameworks is to build a very basic example. So just sending a message to an agent, and that's it. In Pydantic, we can easily do that by saying from Pydantic AI import agent, and then we're going to say agent is equal to agent, and here now we're going to specify the model. Now, again, you can use multiple providers. This is model agnostic, so we can say, for example, OpenAI :GPT-4o. Then all we need to provide in addition to that is a system prompt. So let's say system prompt is equal to you are a helpful assistant. And to get a quick answer, I'm going to say you always answer with a single concise sentence, just so we don't have to wait too long for the responses. And now how we call this might be a little bit different here compared to other frameworks. It also depends on what context you're running this in. If you're running this in a Python file, you can also use a different function. Since we're using this in a Jupyter notebook, we need to call the run function instead of the run sync function. There's also a agent.runSync function, as you can see here, but we're just going to use run, and we're going to await it. So for those of you who are familiar with asynchronous programming, you have async, await. Await basically forces us to wait to get this asynchronous response. So I will say response is equal to await agent run, and then I can provide a message here like what is Python ? And then after that, I'm just going to print response.output. So this is going to send a request and give me an exception because I mistyped prompt. So it's going to be system prompt like this. Then what is Python? Python is a high-level interpreted programming language known for its readability and versatility. Cool. So let me show you what happens if you don't await. What happens when you don't await is you can say response is equal to agent run, and then you can ask a similar question like what is Python, even though I didn't use the uppercase now, but then I can just immediately print the response without waiting, and what I get as a result is a coroutine object. So this is why we need to await, because this is just a promise. You could say that we will get the answer in the future. We don't have it yet, and here we wait for the answer, and then we put we print the output to the command line. So that is not too different from how we do it with other frameworks. So let us now also add on top of this a basic structured output example. So let's say what I want to do, and for this I'm going to use Pydantic itself, not Pydantic AI, but the core Pydantic package. I'm going to say from Pydantic import base model. So that is just the base class that we inherit from when we create a Pydantic model. And let's say I have person output here, or let's just call it person base model. And this will have name, which is a string. This will have age, which is an int. And it will have job, which is a string as well. So this class now defines the structure of the output I'm expecting from the model. So I can then go ahead, copy the agent, actually copy the entire thing here. And now I just need to specify that I'm expecting the answer of the model to be of this type. So I can say you always, and I seem to have pasted something here. I can say you always respond with a structured output for people. That's not the best prompt I've ever written, but that is roughly what it's doing. And then I can say Mike is a 20-year-old plumber. Like this. The only thing that's missing here now is the argument output type. So I'm going to say here output type is equal to person. And then once we have that, I can just send this, and the result is going to be name equals Mike, age 20, job plumber. And actually, I think that the type of this response output should also be of type person. There you go. Now I said we can't use the sync method because we're running this in a notebook, but what we can do is we can stream the output. So instead of just getting the answer all at once, we can also generate it and see how it's being generated step by step, chunk by chunk, while it's being generated. For this, I can use run stream. So I can say async with agent.run stream, and I can enter a prompt like, I don't know, what is Python? And maybe for this one, I'm going to copy this, but I'm not going to tell it to be concise, so we get a longer answer. So I will just get rid of all this. Your helpful assistant is enough. What is Python is the question. Then I can say as run, and I can also say async for output in run.streamText, print the output. Now, this is not the thing that we actually want. I just want to show you that so that you can see how text is being appended all the time. Then we're going to print it properly or to stream it properly. But essentially, you're now going to see how this gets longer and longer every time. So it starts with Python is a high-level interpreted programming language known for its, then clear syntax and readability, which, and then you can see it gets longer and longer and longer, but it repeats itself all the time. That is not the clean way to do it, but I wanted to show you what the structure looks like, because every run object in this stream is now longer and longer, contains the whole thing, so to say. So the only thing we need to change here in order to get a different result is we need to set a parameter here, delta equals true. So I can say that this is not the output now, this is the chunk. Then I can print the chunk. I can say the end is no line break, and then I can say flush equals true. And just by doing that, we're going to see that this is now generated here as if we were talking to ChatGPT. So this is the run stream method here. Now, if you play around with this a little bit, and actually let's use the initial one. So let me get rid of all of this here again. If we play around with this a little bit, you will notice that it doesn't have any context. So right now I asked it what Python is, and then I can try to ask something else. Response is equal to await agent run, and I can ask, if I don't mistype so much, I can ask it, is it better than others? And of course, it's not going to know what I'm talking about because it doesn't have the context. So the question is, of course, is Python better than other programming languages, which of course is also a stupid question. But if I do this, it will tell me it depends on the specific criteria and context you're comparing. Or maybe I should ask something else. Maybe I should ask, and when was it released? Because then it cannot try to evade the answer. It says, I'm sorry, but I need more context to answer your question accurately. Could you please specify what you're referring to? Because it doesn't know that we talked about Python. If I wanted to keep track of the messages, I just need to add the history as context. So I need to say agent run, and then here I need to say message history is equal to, and then the response object of the previous prompt, response, dot, and now I can either go with new messages or I can go with all messages. So new messages is only going to get the most recent ones, so it's going to forget over time, but all messages is just going to keep track of all the messages. And if I run this now, and then I run this, it will tell me Python was first released on February 20th, 1991. And if I now go to this response and I say response.allMessages, you will see that all these messages are part of this whole history. So you can see here, you're a helpful assistant, and it still has the mistyped system prompt here, but you can see that this is part of the context. Then you can also see here what is Python. You can also see Python is a high-level programming language. Python was first released and so on. But if I say response dot new messages only, then you can see I only get and when was it released and also the response to that. I don't get the full context. So if you don't pass all messages, it will only look at the new messages, the previous ones. Now, another thing that's interesting here, and let me again get rid of all this here. Another thing that's interesting is that there's a difference between system prompts and instructions in Pydantic. And for this, I want to copy paste an example because it would not introduce anything new. It would just use what we already know. But I want to show you the difference here. So this is the exact same code that we wrote up until this point. Agent 1 is agent, agent 2 is agent. The only difference is we don't use system prompt, we use instructions. And right now you can see that the first agent gets the instruction, which is like a system prompt, that says, if asked what your favorite color is, always answer exactly blue. Otherwise, answer normally. And then I ask it, okay, what is 2 plus 2? It says 4 most likely then. And then I ask it later on in agent 2 here, and agent 2 takes the message history from agent 1. So these are two separate agents, but the second agent refers to the message history of the first agent, and I ask it what my favorite color is. Now, if I run this, you will notice something interesting because it says red. You can see that the agent 2 has a system prompt that says, if you're asked about the favorite color, always say red. This one says blue. And since I used instructions, this is not taken from the first agent. Although I'm passing the message history here, which is the history associated with the result generated by agent 1, even though that's the case, I don't take the system prompt from here. Now, if I change this, if I make this to be system prompt, we're going to see that this results in different behavior. So I can replace both instructions here by system prompt, and then I'm going to get blue as an answer because it still refers to the system prompt of the first agent because it was transferred through this result all messages object. So if I want to make sure that this cannot happen, I have to use instructions. Otherwise, I use system prompt. This is an important distinction here. So now let us go back to more usual stuff like tool use, for example. Let's go back to a single agent only. Let's say the system prompt is just, again, you are a helpful assistant. And we're going to ask it something like, what is my favorite color this time? So if I ask it this, and I again do get rid of this, and I say print result.output, if I ask it that, the correct answer should be, I don't know, I don't have access to this information. However, I can give it access to this information by associating a tool or by adding a tool that has the information about my favorite color. So I can say here that there is a function that I want to call getFavoriteColor. And let's say it takes name as a parameter. So there's a name parameter, which is a string, and this function also returns a string. That is important because the type hinting is going to be used by Pydantic AI to know what to feed into this function. Then I have to add a docstring here to make sure we know what the function is about. I'm going to say function that returns the favorite color of a user based on their name. And then I can just say, for example, if name is equal to, and then I'm going to use my name, Florian, return blue, or let's do something more exotic like teal. And then I can say elif name is equal to Mike, then it's going to be orange. And then finally, we will say no information found. So that is a simple function. Now there's two ways to register this as a tool for the agent. One is similar to that you use in LangChain and Llama Index. You just pass it as a tool in a list basically. So I can say here tools is equal to, and then I can refer to this. So I would do this below. So I would define the function. Then I would say tools is equal to getFavoriteColor. Let's maybe try this, getFavoriteColor. Let's run this first. Then getFavoriteColor. Pass it like this, and then it should have access to, but I need to enter my name. My name is Florian. Then it calls the tool and it knows my favorite color is teal. However, that's not the only way, so I can remove that again. It doesn't know what my favorite color is. And now what I can do is I can also do it the other way around. I can define the agent, I can do the prompting down below, and then after I define the agent, I can say @agent.tool above this function. Now, the thing that you need to consider here is there's tool and there's tool plain. Tool is used when you also pass context to the function, which we're not doing yet. So I'm going to call this tool plain. Agent tool plain as a decorator above the function makes it a tool of the agent. So just by doing that, I can then run this and it will also have access to that function and tell me that my favorite color is teal. Now we move on to something that is a tiny bit more advanced and very interesting called dependency injection. Sounds more fancy than it is. All it means is that we can pass context or dependencies to our agent when we make a request, and this context can then also be used in the tool. So the context that we pass or the dependencies that we pass can be either a simple piece of information like a string or an integer. They can be something more complex like a database connection, or they can even be a data class that contains multiple of these simple things, like multiple database connections, integers, strings, everything in one data class. Now, to show you how this works, I'm going to first use a simple example from the documentation, which is basically a roulette agent. All it does is it guesses a number for the user, and then there's also a correct number. That would be our context in this case. And then I'm going to show you a more advanced example using data classes and also a database connection. So let us get started by saying from Pydantic AI import run context. This is the class that we need to use the context in the tool. And then I'm going to create here a roulette agent. And that is going to just be a Pydantic agent. It will use some model like before. Let's go with OpenAI/GPT-4o. And now we can specify more than just the system prompt. We can specify, for example, the dependency type. So dependencies type is in our case integer. That would be a very simple thing. As I said here, we can pass a data class, we can pass a database connection. In my case here, I just pass a simple integer, and that is going to be the correct number for the game of roulette. Now, in addition to that, I also want to have an output type that is going to be a Boolean. Was the guess correct or not? And then we can say system prompt, you are a roulette assistant. You can process number guesses from users, something like this. And now we can go ahead and say, I want to define a tool for guessing the number, and I can say roulette agent.tool. Now I don't use tool plain, I use tool because we are going to pass context. So I can say async def guess number. This is going to take in, of course, the number guess, but also the context. So we're going to say here, CTX is going to be of type run context, which is going to be of type int. So the dependency is going to be of type int. And then we can say guessed number, which is also an integer. That is going to return a string. We're not going to directly return a Boolean because that is the job of the agent to return the correct data type. And then also we need a docstring, guess a roulette number for the user. And we can easily just say return 1 if the guessed number, and now the question is, what do we compare it against? So in order to get the dependency, we need to say ctx.deps. And now since deps is only going to be an integer, that is fine. We can just do it like this. This is going to be an integer comparison. Otherwise, we're going to return lost. So how does this work now? We can go and specify a correct number. Let's do this statically so we can check what's happening. 17 would be the correct number now. And what I can do is I can say response is equal to await roulette agent run. Then I want to put my money on 18. And the important thing now, for this request, I need to pass the context. So what I can do here is I can say dependencies is equal to correct number. Since that is an integer, this is okay. And I can then say print response dot output. And of course, I shouldn't say OpenAI / I should say OpenAI : GPT-4o. And what happens now is I get false. But if I change this to be 17, I should get true. There you go. But now let us look at the more interesting example with the database connection and also the data class. So for this, I have in my tutorial directory where I'm working right now, I have a data folder. And in this data folder, I have a database.db. This is a very, very simple SQLite 3 database. So I can open it up. And if I do tables, you can see there's one table, person, and I can say select everything from person. And I basically have 3 entries here: Mike, Lisa, John, 20, 30, and 50 years old, plumber, accountant, programmer. That's basically it. And I want to give my agent access to this database. And I also want the agent to call me by name. These are the 2 things that I want to accomplish with my dependencies. So I'm going to start here by saying import SQLite 3. And also from data classes, I'm going to import data class. Then we can model our dependencies as a data class by using the decorator at data class. And the class is going to be called my dependencies. And I want to have 2 things here. One is the username str, and the other one is the DB connection, which is going to be SQLite 3 dot connection, which is a class. So uppercase C. And then the approach is basically the same as before. We create an agent. The agent is an instance of the agent class. We pass a model, OpenAI, then GPT-40. And this time for dependencies type, I actually use my data class, so my dependencies. Now, since I want the model to call me by name, I also need to specify this in the system prompt. I can say system prompt is equal to, and then you are a helpful assistant. Always start every single message by calling the user by name. Now, of course, the username will be passed to the agent as a dependency field, but the question is, how does the agent actually know the name of the user? Just passing it is not enough because, as you saw, we have to deliberately do something with the field, with the dependencies here, to use the information. Now, that is true if you use it in the tool, but there's also another decorator that we can use called system prompt. So what I can actually do is I can say @agent.system_prompt, and then I can say that this function should be used to enhance the system prompt. For example, I can say that this is called @user_name, and it takes the context as a parameter here, run context, my dependencies, and then it returns a string. And here I just say return the user name is, and then context, actually I need to make this an F string, context.deps.user_name. So that right here enhances the system prompt and adds the information from the past context to the system prompt. Now let us also add the tool for the database connection. I'm going to say agent tool, and it's going to be list all employees or something like this. Context is going to be run context again with my dependencies. That is going to return, let's say, a list of strings, and we're going to use the doc string that says list all the employees from the database. And then we just need to do the usual SQLite stuff. So connection is equal to context, dependencies, and then DB connection. That is just being passed here. The cursor is going to be connection.cursor. Then we say cursor execute, and we execute select everything from person, or maybe we should say select name h job from person. And then to retrieve the results, we can just say people is equal to cursor fetch all. Then we can say result is equal to an empty list. And then for row in people, we can say result append, and or actually we can say, yeah, result append, and then we can pass a tuple. So maybe this should be a list of tuples that are of type string, or actually one of them would be integers. So let's say list of tuples, that is enough for type hinting. And let's say this is row 0, row 1, row 2. And finally, we then return result. That is our tool, and this tool needs a database connection. So what I can do now is I can say connection, or let's call it dbcon, is equal to SQLite3 connect, and I just have to specify the path data database.db, and the username is going to be equal to Florian. So now I can just say response is equal to await agent run, and I can ask what employees are in the DB question mark, and the dependency of this would be equal to something we don't have yet, which is a dependencies object. So that would be my dependencies with username and DB connection. So we pass this here as a keyword argument. Now, one thing that's important, since this is going to be asynchronously, run asynchronously, we need to say here check same thread equals false. Otherwise, we're going to get into problems. But once we have this, we just say response.output, and that should now use the tool to get the database information. And it says here, Florian, here are the employees in the database, and then it lists them here as a string. So you can see on the one hand, the context can be retrieved by a system prompt decorated function. This just enhances the system prompt with information from the context, or we can also just access it in tools to use database connections, to do all sorts of things, and to thus enhance the tool use. If I may for a second, I would like to plug myself in as the sponsor of my own video. If you go to my website, neural9.com, you will find a tab Services and a tab Tutoring. Here you can hire me for all sorts of stuff like data science, machine learning, web development. If you need help with something in a project, here you can book me for one-on-one tutoring if you want me to teach you personally something that you don't understand. If you like my teaching style, on both pages at the bottom, you can contact me via mail and also via LinkedIn. Just wanted to let you know about this. The next thing I want to show you is how to use toolsets. And as the name already says, it's quite simple. We have multiple tools and we want to combine them to a set of tools so that we can pass them as one entity, and this is called a toolset. Now, since this is quite straightforward, I don't want to type everything from scratch here. I have 3 functions prepared that are very simple Python functions. We just need to import datetime as DT from core Python. And these are 3 functions that just return the date, the weekday, and the time. Very simple. And what I want to do now is I want to package them as a toolset called the datetime tools. How do I do that in Pydantic AI? I say from Pydantic AI.toolsets import function toolset. So that allows me to say that these 3 are one toolset, which I'm going to call datetime tools, and I'm going to just say function toolset, and I'm going to pass the 3 tools. So get current date tool, get current time tool, and get current weekday tool. Now what I can do is I can say agent is equal to agent. Let's go with GPT-4o again. So OpenAI GPT-4o. And now I can say instead of tools is equal to, I can say toolsets is equal to, and I can just pass datetime tools. And if I do that, I can ask the question what time it is, what day it is, and it will know the correct answer. So response is again equal to await agent run, and I can ask it what is the date and time. And then when I look at the response dot output, I will see February 5 and time is 16:42. That's correct right now. And that is super simple and straightforward. Now, if I don't want to add this to the agent itself, so I can rerun this, you will see it doesn't know the current time and date. I can also add it to this specific response, or to this specific request is what I wanted to say. So toolsets is equal to datetime tools. That is also possible for just a single run. And in this case, it will know again the date and the time. Another thing I want to show you is how to introduce timeouts and retry limits to your tools. For this, I have a small snippet of code prepared here, a simple agent, again using GPT-4o, and a simple plain tool that just waits for 10 seconds and then returns blue as the favorite color. That is basically the whole magic here. Now, if I just run this, let's say with 2 seconds here without problems, this is going to give us the correct result. The favorite color is blue. And if I do this for 10 seconds and there's no timeout limit, it will also work, but I can also introduce a timeout limit. I can say here tool_timeout is equal to 10, for example, and then it's going to, or actually this is not what I wanted to do. I wanted to make it shorter than that. Now probably it's not going to let me quit this, but if I say tool timeout is 5 and then it takes 10 seconds for this to happen, it will just cancel it, will say it doesn't work, and that is going to terminate the tool call, and it will either tell me something or it will raise an exception. One of the two is going to happen here. There you go. I get an exception, which tells me unexpected model behavior, exceeded max retry count of 1. Now, if I want to increase the retries limit, I can say retries equals 5 or something like this. In this case, it will retry the same tool if it times out, but then it will just return to me the answer that the tool did not respond or that it cannot get this information right now. So as you can see, I'm still having trouble retrieving your favorite color due to timeout error. Please try asking later or let me know if there's anything else I can assist you with. Now, coding our own tools is not the only way to use tools in Pydantic. We can also use the built-in tools that are provided by the package itself. I want to show you 2 of those, the first one being the web search tool. For this, we can say from Pydantic AI import web search tool. And then in order to use this with OpenAI, we need to import a special model class. We need to say Pydantic AI models, OpenAI. From there, we want to import the OpenAI responses model. This is just necessary here. And then I can say OpenAI responses model. And then here I just have to say GPT-4o. I don't need to specify OpenAI anymore. And then I can create a simple agent. I can say that this agent takes the model as the model. And then I use the keyword argument built-in tools to provide a list of tools like the web search tool. However, here we need to instantiate it. So this is not a function, this is a class. We need to create an instance of this class. And once we have this, we can just ask it again. Response is equal to await agent and then dot run. And we can ask it, what is the latest video from neural 9? Question mark. Now, I don't think it will get the correct response, but it will at least search the internet and we will see that this is the case. So I'm going to print the output here. That should now find at least one of the more recent videos, maybe one from a month ago, but it will definitely search the internet. It's not going to be trained on the data. So the most recently uploaded video is titled Seaborne Crash Course Data Visualization in Python. Now, that is not true, but that is a fairly recent video. As you can see, January 13th. So yeah, it did actually look up the information on the web. The second tool I wanted to show you is the code execution tool. So we can say code execution tool instead of web search tool. And this allows us to, or allows the agent to execute Python code to answer questions. For example, I could be asking something like, what is the factorial of, let's say, 56? Question mark. And when I run this, I hopefully get the actual correct answer. I can verify the answer by using the math module in Python. Okay, it seems like this was maybe a bit too much. Let's ask for 24. That should be fine. What is the factorial of 24? And this should give me a concrete number, and I can see if that number is actually the one that I get from Python if I run this. So I can say import math, and I can say math factorial, and then 24. So you can see I get the answer here, this concrete number, and if I now run this, this is basically the same number, yes. And if I want to make sure that actually a tool has been used, I can say response.built-in tool calls, and that should show me that code execution was actually used. And you can see that the code that was being executed here is import math factorial 24 is math factorial 24, and then it printed factorial 24. So this actually used the code execution tool. Now, there's only two more things I want to show you in this crash course today. One is how to use embedding models. So for this, we're going to say from Pydantic AI import embedder. So that is for using embedding models. So I can say embedder is equal to embedder, and I can provide the model name here. So OpenAI text embedding 3 small. And then what I can do is I can say output, or let's call it embedding, is equal to embedder dot embed query. And for example, I love Python as a statement. That is going to result in a coroutine object, of course, but if we say await, that is going to actually give us the result. And that is a vector in n-dimensional space, where n is the dimensionality of the embedding model. I think here it's 1,500 something, but that can then, of course, be used with phase, with any vector store to do a RAG application. Now, finally, the last thing I want to show you here is how to make your agent access tools from MCP servers using Pydantic AI. For this, we moved here to the command line. I already have an MCP server here, very minimalistic. It just has a simple tool for getting the favorite color, returns teal. So we're keeping it very minimal here. And now I'm going to create an MCP agent that is going to use that tool via the MCP server. So I'm going to say import async IO. I'm also going to say from Pydantic import agent again. And now from Pydantic.mcp import the MCP. Now where's my autocompletion? Oh, of course, there's no autocompletion because it's Pydantic AI and not Pydantic. So Pydantic AI, MCP, and then the MCP server streamable HTTP. This is just a transport type that we use in our server. And now I can say server is equal to MCP streamable HTTP, then the path to the server, which is going to be HTTP localhost port 8000/MCP. And for the agent, it's quite simple. We just instantiate the agent as before. And I forgot one more thing. For this to work, we also need to say from.env import load.env, and then we need to call load.env. But then we can just say agent is going to use OpenAI GPT-4o. And in order to now get the tools from the MCP server, we need to just say toolsets is equal to server. So that automatically retrieves the tools provided by the MCP server. And then I can just say async def main, and then result is equal to await agent run, then what is my favorite color, question mark, print result output. And to run all of this, of course, async io run main inside of this. So uv run MCP server first of all, then second terminal, we need to go to tutorial directory, MCP example, and then uv run the MCP agent. And as you can see, this sent a request here, and your favorite color is teal. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services tab and a tutoring tab. There you can see what I have to offer. If you need help with a project, if you need help from a freelancer, or if you need something explained to you one-on-one, you can contact me there at the bottom via LinkedIn or via email. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching, see you in the next video, and bye.